Deep beneath the border of France and Switzerland, a marvel of human ingenuity lies hidden. The European Organization for Nuclear Research, widely known as operates. This groundbreaking facility, stretching a staggering 27 kilometers in circumference, is where some of them have been made. But CERN is more than just a hub of scientific innovation. It's a place where humanity's deepest questions about existence and the universe are tackled. In this video, we'll uncover the incredible work happening at CERN, the groundbreaking discoveries that have emerged, and the potential mysteries lurking within the LHC's depths. From to the tantalizing idea of let's dive into the world of CERN. And stick around till the end, we'll discuss some of the including the possibility of creating black holes or even opening gateways to other realities. CERN isn't just a building or a piece of machinery. It's a collaborative effort involving thousands of scientists, and decades of planning and innovation. Founded in, CERN's mission is simple yet profound. At the heart of CERN is a massive ring-like structure buried underground. Within this collider, subatomic particles are accelerated to near light speeds and smashed together. The results? A cascade of smaller particles that give scientists a glimpse into the building blocks of reality. But CERN's significance extends beyond just physics experiments. It was at CERN whereby one of the most exciting areas of research at CERN is the search for. Our everyday experience is limited to 3 spatial dimensions: length, width, and height, plus time as the fourth. But theories suggest there could be many more dimensions, hidden from view. Why do physicists think higher dimensions exist? In part, because while incredibly successful, can't explain everything. Like electromagnetism. Could it be leaking into another dimension? Fundamental interactions between particles might require higher dimensions to function as they do. Scientists believe that certain phenomena, like missing energy in particle collisions, could hint at particles escaping into higher dimensions. Imagine, what if CERN's experiments could provide? If higher dimensions are confirmed, it would open up possibilities that sound like science fiction. Could we one day manipulate these dimensions? Could they hold answers to faster-than-light travel or even time travel? Another major focus at CERN is a mirror image of regular matter but with opposite charge. When matter and antimatter meet, they annihilate each other in a burst of energy. Antimatter has fascinated scientists for decades, partly because of its connection to the Big Bang. When the universe was born, equal amounts of matter and antimatter should have been created. But for some reason, matter won out, leaving antimatter as a cosmic mystery. Recently, scientists at CERN achieved a breakthrough. They managed to create and stabilize antimatter. While this may not sound like much, it's a huge step forward in studying this elusive substance. Why does this matter? Antimatter could have practical applications in fields like. It could also hold the key to understanding the universe's origins. But it also raises existential. Black holes are some of the most fascinating objects in the universe. With their immense gravity, they can swallow stars and distort spacetime itself. But could CERN accidentally create one? When the LHC collides particles at extremely high energies, it theoretically has the potential to create. However, CERN has reassured the public that these black holes would be tiny, short-lived, and pose no threat to Earth. Still, the very idea has sparked debates among physicists and the public. Could we truly understand all the consequences of creating black holes? Could they grow, defying current predictions? Perhaps the most mysterious substance in the universe is which makes up about. Unlike regular matter, dark matter doesn't interact with light, making it invisible to telescopes. CERN scientists hope to detect dark matter by smashing particles together and looking for missing energy. One of the most promising candidates for dark matter is the hypothetical particle first proposed decades ago. If CERN succeeds in identifying dark matter, it would revolutionize our understanding of the cosmos. What else might we discover hiding in the universe's shadows? The collisions at CERN don't just confirm existing theories, they also reveal entirely new phenomena. For instance, the discovery of exotic particles made of 4 or 5 quarks. The surprising production of in recent experiments. These discoveries challenge the standard model and open the door. In 2012, CERN achieved its most famous milestone, the discovery of the particle that gives other particles mass. This confirmed a key part of the Standard Model, but it also raised new questions. For instance, could there be other types of Higgs bosons? Could they help explain which predicts a hidden symmetry between particles? CERN has not escaped controversy. Some theorists have suggested that its experiments could have unintended consequences, like opening portals to other dimensions. While these ideas are largely speculative, they capture the public's imagination. CERN is at the forefront of humanity's quest to understand the universe. Its discoveries have already reshaped physics, but its greatest achievements may still lie ahead. From to glimpsing, CERN is pushing the boundaries of what we know, and what we think is possible. As we look to the future, one thing is clear: the mysteries of the universe are far from solved. And thanks to CERN, we're one step closer to unlocking them. A vivid depiction of CERN's underground setup. The sheer scale of collaboration across countries and disciplines. How CERN became a symbol of human curiosity. The origins of CERN, why it was founded, and its early milestones. Public misconceptions about CERN's role, debunking myths. A deeper dive into the and its significance. What it would mean for everyday life if higher dimensions were proven. Stories from scientists working on these experiments. Fiction-inspired possibilities: could CERN's discoveries mirror ideas in popular culture, like Interstellar or Stranger Things? A detailed breakdown of how CERN creates and stabilizes antimatter. Antimatter's potential in medicine, space travel, and energy. The challenges and risks of antimatter research. What exactly are microscopic black holes? Real-life physicists' debates over black hole stability. The implications if black holes grew larger unexpectedly. How dark matter was discovered, rotation curves, gravitational lensing. Other candidates for dark matter besides axions, WIMPs, sterile neutrinos. Theories that challenge dark matter's existence: are there alternative explanations? Each quark type's role in nature, with relatable examples. Why tetraquarks and pentaquarks matter to our understanding of the universe. Speculative applications for these exotic particles. A dramatic retelling of the day the Higgs boson was confirmed. What the Higgs field is and why it matters. Potential undiscovered cousins of the Higgs boson. The wildest theories surrounding CERN: portals, aliens, apocalypse fears. The science behind debunking these ideas. Why public imagination is drawn to such narratives. New projects, like the Future Circular Collider, FCC. How CERN inspires young scientists and the next generation of explorers. The philosophical implications of CERN's work: are we ready for answers to the universe's biggest? Imagine walking through a sleek, dimly lit tunnel stretching far into the distance, surrounded by humming machinery that feels almost alive. You're 100 meters underground, standing at the epicenter of scientific discovery. This is CERN, a sprawling labyrinth of laboratories, control rooms, and, of course, the crown jewel. But CERN is more than its machinery. It's a melting pot of cultures, with thousands of scientists from over 100 countries working together. Picture teams of physicists, engineers, and computer scientists speaking different languages, united by a single mission. CERN takes these questions and tackles them head-on, using technology so advanced it might seem like magic to the untrained eye. But what happens when this magic pushes beyond the boundaries of what we can understand? To appreciate CERN's significance, let's rewind to post-World War II. Europe was recovering from devastation, but scientists across the continent dreamed of creating a research center that transcended national boundaries. By that dream became a reality. CERN's early years focused on nuclear research, but its goals quickly expanded to the frontiers of particle physics. By the late 20th century, CERN had built a reputation as the world's leading center for high-energy physics. Its contributions ranged from Nobel Prize-winning discoveries to a tool we use daily without realizing its origins lie deep underground. What if reality is more than meets the eye? In particle physics, this isn't just speculation. It's a hypothesis supported by mathematics. Imagine our universe as a flat sheet of paper floating in a much larger space. That larger space represents that theories like string theory suggest could exist. These dimensions aren't just theoretical curiosities. They could explain why gravity is so weak compared to other forces, how particles interact in ways we can't currently predict, why the universe's fundamental constants are finely tuned for life. CERN's experiments could provide evidence for these dimensions. When particles smash together, scientists look for which could indicate that particles have escaped into another dimension. If these dimensions exist, the possibilities are staggering. What if one day, we could tap into these dimensions to solve humanity's greatest challenges, like creating new energy sources or traveling vast distances instantaneously? Antimatter often feels like something out of science fiction, but at CERN, it's a daily reality. In popular culture, antimatter is depicted as both a source of infinite energy and a potential weapon. But what's the truth? Creating antimatter is no small feat. The process involves colliding particles at speeds approaching that of light, producing tiny amounts of antimatter in the process. In 2021, CERN researchers achieved a breakthrough. They kept a record. Why does this matter? If we could harness antimatter on a larger scale, it could revolutionize using antimatter in cancer treatments. 1 gram of antimatter could theoretically produce energy equivalent to several nuclear bombs, but safely. Antimatter engines could reduce travel time to Mars or beyond. However, challenges remain. Antimatter is costly, creating just 1 gram would cost with current technology. Dark matter makes up, yet we can't see or directly detect it. So how do we know it's there? Through its gravitational effects. Galaxies rotate faster than they should, given the visible matter they contain. This missing mass is dark matter. CERN is on the hunt for dark matter particles, with a leading candidate being axions. If detected, could rewrite the textbooks on cosmology and physics. But what if dark matter isn't made of particles at all? Some alternative theories suggest that our understanding of gravity might be incomplete.